Learn how to use the zero factor property. So what happens when we have two things being multiplied that are set equal to 0? So for example, x plus 5 and 4x minus 7 set equal to 0. Well, if you think about it, whenever you take two things being multiplied, and as long as one of them is 0, the whole thing's 0. 0 times 2, 0. 3 times 0, 0. 4.576 times 0, 0. So with that same type of logic, we just have to find where each one of these things in parentheses, these binomials, are equal to 0. Because as long as one of them is 0, timesing them together, it will become 0. So solving for x in this case, we get x equal to negative 5. Solving for x in this case, we get x equal to 7/4. So if x is 7/4, this one's 0. And when we times them, it doesn't matter what that one is because this one's 0, they will be 0. When x is equal to negative 5, this one's 0. And when you multiply them together, it doesn't matter what this one is because they will become 0. If I have 7x equals 3 minus 6x squared, first, getting everything on the same side, I have 6x squared plus 7x minus 3 set equal to 0. Now, just for sake of time, because we've already learned how to factor, this becomes 3x, 2x plus 3 minus 1, 2x plus 3. So I get 2x plus 3 and 3x minus 1 set equal to 0. So factoring this becomes this. Now I'm at this type of a process again. I say, where does 2x plus 3 equal 0? And where does 3x minus 1 equal 0? Well, that's where 2x equals negative 3, x equals negative 3 halves, 3x equals 1, x equals 1/3. So these two spots are where this becomes 0, as long as one of them is, timesing them together, they both will be. Working a couple more examples. So let's say, for example, that I have 16x squared plus 40x plus 25 set equal to 0. First up, I say, is there anything common I can pull out? There isn't, but this actually factors to become 4x plus 5 and 4x plus 5. Well, since they're the same, there's going to be only one spot where they are equal to 0, and that's at negative 5/4. And in this case, both will be 0 when we plug in negative 5/4, which doesn't happen very often, but sometimes. Another option is if we have 3x squared plus 12x equal to 0. So notice how when we had a trinomial, we have to factor first. In this case, we can actually just pull out what's common, and it creates it already into the factored form. And we say, well, where does 3x equal 0, and where does x plus 4 equal 0? Well, that's at 0, and that's at negative 4. And those would be our two solutions. Another option would be if I have something like 4x squared minus 100 equals 0. Difference of squares, 2x squared minus 10 squared equals 0. So I get 2x minus 10, 2x plus 10 equals 0. 2x minus 10 equal to 0, 2x plus 10 equal to 0, 2x equals 10, x equals 5, 2x equals negative 10, x equals negative 5. So these two spots would create a 0 in this formula. Two more examples. So say, for example, that we have, this is example 6, x plus 3 2x minus 1 equals 4x plus 4 minus 4. Well, first thing we have to do is get everything on the same side and together with its like pairs. So we actually have to FOIL. So we get 2x squared minus x plus 6x minus 3, distributing 4x plus 16 minus 4, combining like terms, 2x squared plus 5x minus 3, 4x plus 12. So these two combine to make that, these two combine to make that. Getting everything to the same side. So this side becomes 0. We get 2x squared plus x minus 15. So if I factor this now, it actually becomes 2x, x plus 3 minus 5, x plus 3, set equal to 0, or x plus 3, 2x minus 5, set equal to 0. That means one option is x plus 3, one option is that. So I get x equal to negative 3, 2x equal to 5, x equal to 5 halves. And those would be my two solutions that would make this whole thing 0. So the first thing you need to do is completely get rid of the parentheses, combine your like terms all to the same side, and then you can factor and set equal to 0. (12) equals 2x cubed plus 5x squared. So subtracting the 12 over, 12x. We get 0 equals 2x cubed plus 5x squared minus 12x. First, we're going to pull out what's common, which is an x, reducing each term by 1 power of x. Factoring this, so the x stays out front. This factors to become 2x minus 3 and x plus 4. So then I say, well, x could be 0, 2x minus 3 could be 0, or x plus 4 could be 0. This one's already solved. There's one option. Solving this one, we get 3 halves. Solving this one, we get negative 4. So there's the three options that make this equal to 0.